All right, let's start this section by a discussion of variables and the built-in primitive types in Python, including integers, floats, booleans, and strings. So here I'm going to define a few variables, starting with the first one, students count. Note that here, all the letters are lowercase, and we're using an underscore to separate multiple words. This is the naming convention we use in Python. So here we set students count to, let's say, 1,000. This is an example of an integer. Let's look at an example of a float. So we set rating to 4, let's say 99. Here's another variable, is published. We set this to true or false. Note that the first letter is uppercase. And finally, let's take a look at an example of a string. So we set course name to Python. Now in Python, you can use either double quotes or single quotes, or you can use triple quotes if your string is multiple lines. For example, here I can put triple quotes, and in between them, I can add a string that has multiple lines, okay? Now, one interesting feature in Python is that you can initialize multiple variables on the same line. For example, let's say we have coordinates like x and y. We can initialize these two on the same line. So we can set x comma y. We set it to 1 comma 2. This line is exactly equivalent to these two lines. So it's a shortcut. And finally, just like almost every programming language, we can set multiple variables to the same value. For example, we can set x and y to 1. So these are the basics of variables. Next, I'll talk about the dynamic nature of Python. In terms of typing, programming languages fall into two categories: static languages like C++, C#, and Java, and dynamic languages like JavaScript, Ruby, and Python. In static languages, when declaring a variable, we need to specify its type. For example, in C#, when declaring this variable, we need to set its type to an integer. So with this, the type of this variable will always be an integer. When we compile this program, our compiler knows that students count is an integer. So if we accidentally try to set it to, let's say, a boolean later on, the compiler will complain. This is how static languages work. In dynamic languages like JavaScript and Python, we don't have this behavior. So we don't set a type when defining a variable. We just define a variable by setting it to a value. So in dynamic languages, the type of a variable is determined at runtime. Now here, if you hover your mouse over students count, you can see this is an integer. So when working on a large complex program, if you want to know the type of a variable, you can simply hover your mouse over it. We also have this built-in function called type. We can pass a variable or an object to it, like students count, and then print this on the console. So let's run this program. You can see the type of students count is a class of integer. What is this? Python is an object-oriented language, so here we have the concept of classes. If you're not familiar with classes, don't worry, I'm going to talk about them in detail later in the course. All I want you to know now is that in Python, we have a class called int that represents integers. So all integers are instances of this class. Let's take a look at a few more examples. So here in this interactive shell, let's look at the type of a float. Once again, it's a class called float. Let's look at type of a boolean. This is also a class called bool. And finally, let's look at type of a string. That's a class called str. So here's the takeaway. Python is a dynamic language, which means the type of variables are determined at runtime as opposed to compile time. So in the last lecture, you learned that Python is a dynamic language, which means the type of variables is determined at runtime. So here we have this variable age set to an integer. Now we can reset this to a string. This is perfectly valid Python code. So if we print age and run this program, you can see our program is running successfully. Now, if you come to Python from a static language like C# or Java, you probably don't like this. But the good news is that in Python 3.6, we have a new feature called type annotation or type hinting. So we can annotate our variables with their type. So we add a colon here and then int for integer. Now, when I save the changes, everything is still valid. If I run the program, there are no errors because Python is a dynamic language. However, there is a new linter called mypy that checks for these type annotations. So if you define a variable as an integer and then set it to a string, mypy is going to complain. Let me show you. So open up the command palette and type select linter. Currently, you can see we're using pylint. In this list, select mypy. Now, the first time you do this, you're going to see a message on the bottom right corner of the screen telling you that mypy is not installed. So go ahead and install that. Now on line 2, you can see a red line under H. Let's have a look here. So mypy is giving us an error, incompatible types in assignment. So this is all about type annotation or type hinting. So here we have this variable x set to 1. When we run this program, Python interpreter will allocate some memory to store this number 1. So our x variable is purely a label for that memory location. Let me show you. So here we have this built-in function called id. We can pass a variable here like x, and this will return the address of the memory location that x references. So now let's print this on the console. There you go. So this is the address of the memory location where we have stored number 1. Now, one thing you need to know about the built-in primitive types that I've talked about so far, like numbers, strings, and booleans, is that all these types are immutable, which means their value cannot change. So here, if we try to update x, Python interpreter is going to allocate some new memory to store the updated value. In other words, what we have at this original memory location will not be affected because integers are immutable. Let me show you this. So here, after we print the ID of x, I'm going to increment x and print its ID one more time. See what we get? We get 2 different addresses. So our x variable or x label was originally referencing this memory location. At this memory location, we have the number 1. Because integers are immutable, we cannot change the value at this memory location. So on line 4, when we update x, Python interpreter will allocate some new memory at this location, and then x will reference this new memory location. Now, because we don't have a reference to the original memory, at some point, Python garbage collector will automatically release this memory. So this is how immutable types work. Now let's see what would happen if x was set to a mutable type. Here's an example. So in Python, we have a concept called lists for storing a list of objects. So here we use square brackets to indicate that this is a list. We can add multiple objects here. Now on line 4, let's add a new number to this list. So we call x.append and pass 4 here. Now let's run the program one more time. So as you can see, the address is not changed because lists are mutable. So whenever we change them by adding new objects to them or removing existing ones, the changes are applied at the same memory location. So this is the difference between mutable and immutable types. Over the next few lectures, we're going to take a closer look at strings. So here we have a variable of type string. To get the number of characters in this string, we use the built-in len function. Now look at the IntelliSense. This function returns the number of items in a container. So it's not specific to strings. It's a generic reusable function. We can pass a string here, and this will return the number of characters in the string. Or we can pass a list, and this will return the number of items in the list. So here let's pass this course variable and print the length. So we have 18 characters. Beautiful. Similar to many other languages, we can access individual characters using square bracket notation. So to get the first character, we use square brackets 0 because the index of the first character here is 0. Now let's print this, run the program, so we get P. Now, one interesting feature in Python that I personally haven't seen in other programming languages is a negative index. So here, let's duplicate this line and pass -1. What do you think we're going to get? Well, if 0 represents the first character, -1 takes us back to the end of the string, so it returns the first character from the end of the string. Let's run this program. So we get G. Similarly, we could pass -2, and this will return the second character from the end. Very powerful. Now, using a similar syntax, we can also slice strings. So let's duplicate this line. To slice a string, we need to pass 2 indexes. The start index, colon, the end index. So this will return all the characters starting from the start index all the way up to the end index, but it doesn't include the character at the end index. In this example, it's going to return 0, 1, and 2, these 3 characters, but not the character at index 3. Okay, so let's run the program. We get the first 3 characters. Beautiful. Now we can exclude either or both these indexes, and Python will assume default values. So let's duplicate this line and exclude the start index. What do you think Python is going to put here? It's common sense. It's going to pass 0 as the start index. So let's run the program. You can see we get the same result. So these last 2 expressions are exactly the same. Now, what if we exclude the end index? What do you think Python is going to put here? It's going to pass the length of the string. So let's run the program. You can see this returns the entire string. And finally, if we exclude both the start and end index, again, we get the same result. So let's verify this. Beautiful. Now, one thing you need to take into account here is that whenever we access an individual character or a range of characters, Python interpreter is going to allocate some new memory and copy those characters into that new memory location. Because as I told you before, strings are immutable. So the value that we have at the original memory location, that is Python programming, will not be affected. We can verify this. So let's print ID of course, and then print ID of course of 0. And then run the program. You can see 2 different addresses here. That is because strings and other primitive types like numbers and booleans are immutable in Python. Here we have this message variable set to the string, Python programming. Now let's say we want to display a double quote right here. The problem we have is that this second double quote indicates the end of the string, so Python interpreter will not be able to run this code. Now there are 2 ways to solve this problem. One way is to replace these double quotes at the beginning and end of our string with single quotes. So single quote here and one more here. If we run this program, we see this double quote just before programming. Beautiful. But let's say for whatever reason, we want to use double quotes here, perhaps to be consistent with the rest of our code. So how can we display another double quote in the middle of the string? Well, in Python, we have a concept that is borrowed from the C language that is called escape character. So in Python strings, backslash has a special meaning and we refer to it as an escape character. So Python interpreter sees this backslash as a special character. It has a special meaning. And depending on the character that comes after that, it will interpret it differently. Let's see this in action. So now when we run this program, We can see our double quote here, but the backslash character is not there because backslash is an escape character. So in this case, it's used to escape the double quote. Now we refer to these two characters as an escape sequence. In Python, we have a few other escape sequences that you should be aware of. Let me show you. So this hash sign is an indication of a comment line, so it's not executed. You have seen backslash double quote. We also have backslash single quote for displaying a single quote in our string. We also have double backslashes. So if you really want to have a backslash in your string, you should prefix it with another backslash. Here is an example. Let's run this program. And here's our backslash. And finally, the last escape sequence is backslash n, which is short for new line. So here, if I add a backslash n and run this program, you can see programming is on the second line. Now, this is okay for a simple string like Python programming here, but if you're trying to format a complex string into multiple lines, it's better to use triple quotes. Otherwise, you will end up with a lot of backslash n sequences, and that looks pretty ugly. So here we can use triple quotes and simply add Python, new line, programming. So when we run this program, we get exactly the same result as before. Well, not quite exactly, because here we have one new line on the top. That is because I put Python on a new line. If I put Python right in front of double quotes, run the program again, that new line disappears. So here are the escape sequences in Python. Here we have two variables, first and last. Let's say we want to print my full name on the console. So we can define another variable, full, set it to first, then concatenate it with a space, and one more time concatenate it with last. Now when we print full, we get my full name on the console. Beautiful. Now this approach of using concatenation to build a string is okay, but there is a better and newer approach. We can use formatted strings. So here we can set full to this string and prefix it with an f, which can be lowercase or uppercase. This formatted string doesn't have a constant value like these two strings here. It's actually an expression that will be evaluated at runtime. So here we want to add our first name. We use curly braces to print the value of the first variable. After that, we add a space, and then we add curly braces one more time to print the last name. So at runtime, this expression will be evaluated. What we have in between curly braces will be replaced at runtime. Now let's run this program one more time. We get the exact same result. Just be aware that you can put any valid expressions in between curly braces. So earlier you learned about the built-in len function. We can call len here to get the length of this string. Let's run this program one more time, so we get 4. We can also replace last with an expression like this, 2 plus 2. Let's run this program, we get 4 and 4. So when using formatted strings, you can put any valid expressions in between curly braces. In this lecture, we're going to explore a few useful methods of string objects in Python. So this course variable we have here is a string object, which means we can use the dot notation to find all the methods or functions applicable on strings. Here we have a large list of functions, or more accurately, methods. In this lecture, I'm going to quickly show you a few of them. You can learn about the rest on your own. So here, let's say we want to convert this course to uppercase. We can use the upper method and print the result, and we'll get this uppercase string here. Similar to that, we have lower to convert it to lowercase. We also have title, which will convert this to title case, which means the first character of every word will be uppercase. And this is useful for blog posts, product titles, courses, and so on. So let's run this one more time. We get this string here. Another useful method is strip for trimming white space. So if we have a couple of extra white space at the beginning or end of this string, we can get rid of them using the strip method. And this is useful when you get input from the user. So print course.strip, save the changes. Note that in the previous examples, you can see those extra white spaces at the beginning, but when we call the strip method, those spaces are gone. We also have left and right strip for removing the white space from the beginning or end of this string. Now, if you want to find the index of a character or a substring in your string, you can use the find method. So let's print course.find. Let's search for pro. Run the program. So the index of pro here is 9. Now, if I change this to lowercase p, we'll get -1 because string comparisons are case sensitive and we don't have these exact 3 characters in our course variable. Now, if you want to replace a character or a sequence of characters, you can use the replace method. So let's print course.replace. Let's replace all capital P's with a hyphen. And with this, we'll get this weird string here. And finally, to check for the existence of a character or a sequence of characters in your string, you can use the in operator. So let's see if we have programming in this course object. Let's run the program and we get false because I realized that I missed the letter R here. So let's run the program one more time. This time we get true. Now we also have the not operator, so you can prefix this with not. And this time we'll get false. So we have covered strings. Now let's look at numbers. We have a few different ways to represent numbers in Python. We can use decimal numbers that you have seen before. We can also represent them in binary format. So we prefix the number with 0b as in short for binary, and then we'll add individual bits. For example, 0b10, which is the number 2 in binary system. Now let's print x. We'll get 2. If you want to print the binary representation of this number, you can use the built-in bin function. So bin takes any numbers and returns its binary representation. There you go. We can also represent numbers in hexadecimal format. So we set x to 0x as the prefix, and then we'll add our hexadecimal number. Let's print x. So we get 300, which is in the decimal system. If you want to print this in the hexadecimal format, you would use the built-in hex function. Let's run this program one more time. And now we get 0x12c. Beautiful. In Python, we also have support for complex numbers. So complex numbers in math take the form a plus bi. If you're not familiar with this, don't worry. This is a concept used in mathematics. So if you want to use Python to build web applications, you're never going to use this. But very briefly, let me show you how you can represent complex numbers in Python. So here we can set x to 1 plus 2j. So j in Python is like I or imaginary number in math. You can use either lowercase or uppercase j, whatever you prefer. Now let's print x. We'll get this complex number here. In Python, we have all the arithmetic operators that you have probably seen before. For example, we can set x to 10 plus 3. We have addition, we have subtraction, multiplication, division, but we actually have two kinds of division operators. Let's look at the first one. So print x. As you can see, the result of this division operator is a floating point number. If you want an integer, you would use a different division operator, that is double slash. Let's run this program. So we get 3. We also have modulus, so that is the remainder of a division. And finally, we have exponent, that is left to the power of right. So here, 10 to the power of 3 is 1,000. Now, for all these operators here, we have an augmented assignment operator. What do I mean by that? Let's say we want to add 1 to x. We can write a statement like this. So x equals x plus 1, or we can use an augmented assignment operator. So x plus equals 1. These two statements are exactly the same. And what we have on the left side of the assignment operator can be any of these arithmetic operators here. And one last thing before we finish this lecture. In Python, unlike languages like JavaScript or C#, we don't have the increment or decrement operators. So we don't have x plus plus or x minus minus. In this lecture, I'm going to show you a few useful functions for working with numbers. So let's set x to 3.14, or actually let's rename this to pi. Note that here I have used uppercase letters to indicate that this is a constant. In Python, unlike languages like C# and JavaScript, we don't have constants. We only have variables. So if we define this, there is nothing that stops us from changing the value of this variable. So by convention, we use uppercase letters to tell other developers in the team that this pi is a constant and it shouldn't be modified. Now, let me show you a few useful built-in functions to work with numbers. If you want to round a number, you can use the round function. So let's pass pi here and print it. So we get 3. We have another useful function, ABS, short for absolute, and it returns the absolute value of a number. So if we add a minus sign here, when we print this, we'll get 3.14. Here you go. Now, to see the complete list of built-in functions in Python, here in Google, search for Python 3, make sure to add the version number, and then add built-in functions. On this page, you can see all the built-in functions in Python. Now, in this list, we only have a few functions to work with numbers. If you want to perform complex mathematical computations, we have a separate module for that. That's the math module. So back to our code. On the top, first we need to import the math module. Now, math is an object with a bunch of useful methods for performing mathematical computations. So here we can use the dot notation to see all these methods available to us. For example, we can use math.floor to get the floor of pi. And this returns -4 because here we are using a negative sign. If you want to see the complete list of functions or methods in the math module, search for Python 3 math module. Here on this page, you can see all the functions and their description. Quite often when we receive input from the user, that input comes as a string, and there are times that we need to convert that string to a different type. Here's an example. We have this built-in function input. We can add a label here like x. This returns the user's input as a string, so we store it in this variable. Now let's imagine y should be x plus 1. Now when we run this code, we're going to get an error. Let me show you. Don't run this using the code runner because code runner runs this code in the output window, which is read-only, so you won't be able to enter a value. So open up the terminal by pressing Ctrl and backtick and run Python if you're on Windows or Python 3 if you're on Mac, app.py. Let's add one here. Look, we get this error. type error. This is happening because Python doesn't know how to interpret this expression. Because here we have two different outcomes. If x is the string 1, one outcome is to convert this other operand here to a string, and the result would be 11. The other outcome is to convert x to a number, so we'll have 1 plus 1, and the outcome will be 2. So Python doesn't know how to do type conversion here. And that's the reason we say Python is a strongly typed language, because it doesn't do any implicit type conversion on your behalf. You have to explicitly tell Python how you want your objects to be converted to the right type. JavaScript, on the other hand, is a weakly typed language, so it does perform implicit type conversion for you. Now, to solve this problem, we need to use one of the built-in type conversion functions. We have int, float, bool, and stir or string. Now, in this case, we don't need to use string here because we already have a string and there is no reason to convert a string to another. But there are times that you may want to convert an object to a string. So just be aware of this function. Now, let's take a look at what these functions return. And let's delete line 2 because this is the bad boy here. Save the changes. Back in the terminal, let's run the application one more time and enter 1. So here's what we get. Number 1 as an integer, 1.0, which is a float, and true. So int and float are pretty self-explanatory, but bool requires a little bit more explanation. Because in Python, similar to JavaScript, we have this concept of truthy and falsy values. So here are the list of falsy values. Empty strings, number 0, empty lists, and none, which is an object that represents the absence of a value. This is exactly like null in C-based languages. So if we have any of these values and we try to convert them to a Boolean using the bool function, the result will be Boolean false. Anything else will be true. Let's take a look at a few examples. So here in the interactive shell, I told you that number 0 is considered falsy, so when we convert it to bool, we'll get false. Any other numbers are true or truthy. So here's an example, bool of 1 is true. If we add a negative number, we also get true. As for strings, an empty string is falsy, so we get false. Any other strings is truthy. So even if I add the string false here, the result is true because this is a non-empty string. So here are the falsy values in Python. Whenever these values are used in a Boolean context, they will be equivalent to Boolean false. All right, now let's talk about conditional statements. So I'm going to start by defining a variable age and setting it to 22. Now let's see if age is greater than or equal to 18. So in Python, we have these comparison operators, just like the other languages that you have worked with. We also have equal and not equal. Now let's revert this back to greater than or equal to 18. Now here's an interesting fact about Python. In Python, we don't have braces, which means we're not going to spend 2 decades fighting over where to put these braces. Shall we put them here or here? No more nonsense like that. It's over. That's it. No more. So instead, we put a colon at the end of this line. Now note that when I press enter, this cursor is automatically indented. So we use indentation to specify a code block. Here we can add a print statement, adult. We can have another print statement. This is also part of this block. Now to terminate this block, we simply remove the indentation. Now here we can have 0 or more else if blocks. In Python, we call them elif. Here we add another condition like if age is greater than or equal to 13. Once again, we have indentation. Let's print teenager. And finally, optionally, we can have an else block. Once again, colon, print with one or more statements. In this case, we want to print child. Finally, we'll have, let's say, all done. Now, note that currently we have 2 spaces for indentation. But when I save the changes, AutoPEP8 kicks in and reformats our code according to PEP8. According to PEP8, we should use 4 spaces for indentation. Take a look, save the changes, now we have 4 spaces. You can also use tabs, but only if you're maintaining a code that is written with that style. If you're starting a new project, prefer 4 spaces as the standard, but you cannot mix tabs and spaces in Python 3. That's not allowed. Now let me show you a shortcut. So here in a new file, let's just type if, look at these 3 items with this square icon. These are code snippets. So here on if else, I press enter and this automatically generates this snippet. This came with the Python extension that we installed at the beginning of the course. So here you can change the condition to whatever, x is greater than 1. What is this pass keyword? This is basically a statement that doesn't do anything. It's here purely to fill this if block because we cannot have an empty if block like this. If I save the changes, look, we have this red underline here. That is not valid Python code. So if you want to have just an empty block, you use the pass keyword. In Python, just like the other languages, we have 3 logical operators. We have the logical AND, the logical OR, and NOT. Let's take a look at a few examples. So I'm going to start by defining a variable name, setting it to Mosh. Now, let's say this is the input that we get from the user. We want to check to see if name is an empty string. How do we do that? Well, earlier I talked about the falsy values in Python. So we have 0, empty string, none, and an empty list. These are all considered falsy. So let's talk about an empty string. If this is interpreted as false, then if we apply the not operator on it, we'll get true, right? So to check to see if name is an empty string, we can simply write a statement like this. If not name colon. That's it. Print name is empty. Now let's run this program. Obviously, we don't get that message. However, if I change this to an empty string and rerun the program, we get name is empty. But what if I add a white space here? Well, white space is not considered truthy because it's not an empty string. So look, if I run the program, we don't get the message. To fix this issue, we can simply call .strip method to get rid of all the white space. Now, let's run it one more time. Beautiful. So this is our not operator. Let's take a look at an example of AND. So I'm going to set age to 22. Now let's see if age is greater than or equal to 18 and age is less than 65. We say you are eligible. Good. Pretty easy, right? Now here's a question. How do we write that expression in math? We write it like this. Well, more accurately, we should add the equal sign here. So age is between 18 and 65, right? Now I have good news for you. In Python, you can simply write this expression. That's perfectly fine. This is what we call chaining comparison operators. So we can rewrite this expression in a simpler and more meaningful way. This is one of the reasons that Python is a highly popular language because the syntax is so clean, without any clutter, it's easy to understand, and it comes with all these best practices and standards for writing clean code. So let's rewrite this to 18 like this. Good. Now let's run the program. Obviously, this person is eligible. So here we have this piece of code similar to what we wrote in the last lecture. If the person is 18 years or older, we set the message to eligible, otherwise we set it to not eligible. In C-based languages, we have this operator called ternary operator that allows us to rewrite this piece of code in a more compact way. Let me show you how that looks like. So we set message to, we add our condition. So if age is greater than or equal to 18, we add a question mark. If that is true, we set the message to eligible. Otherwise, indicated by a colon, we set it to not eligible. If you have worked with C#, JavaScript, C++, Java, you have seen this before. If not, don't worry. Let me show you the Python way. So in Python, we can rewrite this expression almost in plain English. So message is eligible if age is greater than or equal to 18. Otherwise, it's not eligible. Isn't that easy? So this is the ternary operator in Python. In Python, we have two types of loops. So unlike some languages that have 4 or 5 different kinds of loops, here we only have 2 types. We have for loops and while loops. Their syntax is very simple and clean. Let me show you. So we start with the for loops. With for loops, we can iterate over any object that is iterable. Here are a few examples. We can iterate over strings. So for x in Python, because strings in Python are iterable, which means we can iterate over them. So in each iteration, our loop variable x will hold 1 character. Let me show you. So we terminate this line with a colon, just like our if clauses. Now we use indentation to specify the block of statements. So we simply print x. Run the program. This is what we get. Here's another example. We can loop over lists. So let's say we have a list of names, A, B, and C, colon, print x. There you go. So we get A, B, C here. Now, what if we want to loop over a sequence of numbers? That's when we use the built-in range function. Let me show you. So for x in, we call the range function pass a number like 5. Look at what happens. Now, to keep this example clear, I'm going to comment out these few lines. So the shortcut on Mac is Command and slash. On Windows, it's Control slash. Now, let's run this program. So when we call range of 5, we get numbers 0 to 4. We can pass a starting number like 2 to 5. Let's run this one more time. So now we get 2, 3, 4. We can also pass a third argument here called step. Let me show you. So I'm going to change this to 0 to 10. Let's say we want to display all the even numbers between 0 to 10. So we pass 2 here. That is our step. Now when we run the program, we get 0, 2, 4, and so on. Now, one thing you need to understand about this range function is that it does not return a list. Let me show you. So I'm going to comment out these 2 lines as well. Let's just print range of 5. What do we see? We see range of 0 to 5. We don't see a list object. In contrast, if we had a list like 1, 2, 3, 4, 5, see? This is how we see a list printed in the terminal. So what is returned from the range function is not a list. It's a different kind of object. It's a range object. Let me show you. So here, I'm going to call the built-in type function. Now, let's look at the type of this object. It's an instance of a class called range. So our range function returns a range object. Range objects in Python are iterable like strings and lists, so we can use them in for loops. Now, what is interesting about these range objects is that they take a very small amount of memory. So here, if we pass, let's say 5 billion We are not going to get a list of 5 billion elements. We have a small object that can be iterated over. In each iteration, it will produce a new number like 1, 2, 3, 4, and so on. In contrast, if we had a list of 5 billion items, that list would take significant amount of memory. So this is the difference between list and range objects. So here we have a list of names. Let's write a simple program and check to see if we have a name that starts with J in this list. So we can use our for loop for name in names. Now, if name that starts with J, perhaps we want to display a message like found. Now, if this list has a million objects, as soon as we find the first object, we want to jump out of this loop. We don't want to continue looping for performance reasons. So this is where we use the break statement. You have probably seen this before. When Python interpreter sees this statement, it will terminate this iteration. So now we jump out of this loop. Let's add another scenario to this program. If we loop over all the names in this list and we don't find a name that matches our criteria, perhaps we want to display a different message to the user like, hey, we couldn't find a name that starts with J. So typically how we implement this in other programming languages is like this. On the top, we define a flag like found and set it to false. Then here, as soon as we find an object that matches our criteria, we set this flag to true. And then after our for block, we check to see if not found, we print not found. Let's save the changes. Good. Run the program. Obviously, we have a name that starts with J, so found, beautiful. Now let's change this to A John. Run the program, not found. So our algorithm is working properly. But in Python, there is a cleaner way to implement this scenario. We don't need this found flag. So let's delete it from here and here. All we have to do is to get the same result is to change this statement to else. So we have 4 else blocks in Python. This else clause is executed if our for loop completes successfully without an immediate break. So if we iterate over all the objects in this iterable, then this else clause will be executed. So now, when we run this program, we get the exact same result. The other type of loops we have in Python are while loops. So let's build a simple guessing game. I'm going to define 2 variables, guess set to 0, and answer set to 5. Now we can write a while loop like this. While answer is not equal to guess, once again colon, here we have indentation, we can get the input from the user, make a guess. Now as you know, this returns a string, so we need to convert this to an integer and then store it in the guess variable. Now as I told you before, this code runner extension runs our code in the output window, which is read only, so we cannot enter values there. To fix this issue on the top, let's go to Preferences, Settings, then click here and open settings.json. Now here we need to add a new setting that is code-runner.run in terminal. By default, it's false. We need to set this to true. Save the changes. Now when we run this program using code runner, it runs it in terminal. So here in terminal window, let's add a number like 1, 2, 3, 4. As soon as we enter 5, the game stops. So this is our while loop. Similar to for loops, we have an else block here. We can optionally use that. This is only executed if the while loop completes successfully without using a break statement. To define a function, we start with the keyword def, which is short for define or function definition. Here you can see we have a few code snippets. The first one is for defining a function. So just press enter. So here's the basic syntax. We start with the function name, like increment. Now press tab. In parentheses, we define parameters if they exist. In this case, let's add a couple of parameters like number and by. So we want to increment a number by a given value, right? Also, you can see this line is terminated by a colon, and right after that, we're using indentation to specify the body of this function, just like our if and for clauses. Now we can call this function like this. So increment, parentheses, give it a couple of values like 2 and 3. Now note that when I save the changes, you're going to see 2 line breaks after this function. So save, there you go. So we have 2 line breaks because that's the style that PEP8 defines. So we should always have 2 line breaks after our functions. Now these functions by default return the none or null value. So even though we don't have a return statement here, this function is still returning a value. Let me show you. So print the return value of increment and run the program. Look, we get none. Now let's return a value like number plus by. Run the program again. Now we get 5. Beautiful. In Python, unlike many other languages out there, we can return multiple values from our functions. We simply put them in parentheses. So here we add parentheses. Let's say we want to return the original number as well as the updated number. So number, comma, number plus by. Now let's see what we get when we run this program. So run it. So in parentheses, we get 2, which is the original number, and the updated number. What is this? This is what we call a tuple, which is basically a read-only list. So earlier in the course, you have seen lists like numbers. We use square brackets, 1, 2, 3. This is a list. We can add new objects to it. We can remove existing objects. A tuple is like a list, but we cannot modify it. So we cannot add new objects to it. We cannot remove existing objects. Now, to convert this list to a tuple, we use parentheses instead of square brackets. Okay? Delete. Another useful feature we have here is called keyword arguments. So currently, if someone looks at this code, they may not be able to tell what exactly these arguments are for. We can use keyword arguments to make our code more readable. For example, here, we can prefix this second argument with something like this, by equals. Now we can read this code like plain English, increment 2 by 3. So this is what we call a keyword argument. It's just a way to make our code more readable. Also, similar to a lot of languages out there, we can assign default values to these parameters. For example, we can set a default value for the by parameter. So now we don't have to pass a second argument here. And when we run this program, the value of by will be set to 1 by default. And one last thing before we finish this lecture. Earlier I talked about type annotation or type hinting. We can use that feature in our functions as well. So here we can annotate these parameters as well as the increment function itself. So here we add colon int for integer, and here also colon int. And finally, for the function itself, before this colon that terminates this line, we need to add an arrow, and then we'll add the return type of this function, so integer as well. Now, in this case, we have a red underline here because I annotated this function to return an integer, but I'm returning a tuple. So more accurately, this should be tuple. Save the changes and the error is gone. There are times that you may want to pass an arbitrary number of arguments to a function. Here's an example. Let's say we have a function called multiply that currently takes 2 parameters, a and b. And this function would simply return a times b. And then we can call it like this. So far, so good. But what if we want to pass a variable number of arguments here, like 4 and 5? Well, one way is to put these arguments in a list. Then we need to replace these two parameters with a list. And we should also change the implementation of this function. Here we need a loop to iterate over this list and multiply all its elements. That is perfectly fine. However, this syntax is a little bit noisy. Wouldn't that be nicer if we could pass these numbers or these arguments here without these additional square brackets? Let me show you how to do this. So all we have to do is to prefix this parameter with an asterisk. Now let's print list and see what we get when we call the multiply function. So save the changes, run the program. What do we get here? We get a tuple because of this parenthesis. So when we add an asterisk before a parameter, Python will see that parameter as a tuple. So when we pass an arbitrary number of arguments, Python will automatically package them into a tuple. Now, as I told you before, a tuple is like a list, so we can loop over it, get all the numbers, and multiply them together. Let me show you real quick. So we start by defining a variable, total, we set it to 1. Next, we need a loop. So for number in list, colon, here we simply do total times equal number. And finally, we return total. Save the changes. Good. Run the program. Actually, I forgot to print the results, so let's print it here. Run it one more time. So here's the total. In the last lecture, you learned about the syntax for passing a variable number of arguments to a function. We have a variation of this syntax, and that's what I'm going to show you in this lecture. So let's start by defining a function. Call it save user. Here we add one parameter, user, but instead of one asterisk, we use double asterisks. So first, let's print this user parameter here and see what we get when we call this function. So save underline user. Now, instead of passing an arbitrary number of arguments here, we should pass an arbitrary number of keyword arguments. Remember keyword arguments? Name equals value. So here we can pass multiple properties about a user. For example, we can pass ID equals 1, name equals admin, and so on. So here we have 2 keyword arguments. Let's run this program and see what we get when we call this function. So save the changes and run. This is what we get. Look at the syntax. Here we have curly braces, and in between them we have multiple key value pairs. Here's the first one, here's the second one. This is what we call a dictionary. If you're a JavaScript developer, this syntax is familiar to you. This is like an object in JavaScript. Now, if you're not familiar with JavaScript objects or dictionaries in general, don't worry. Later in the course, we have a comprehensive section about data structures in Python, and there I'm going to cover lists, tuples, dictionaries, and so on. Now, to finish up this example, here we can use square bracket notation to get the ID or name of a user. Let's run this program one more time. So ID is 1 and name is admin. Beautiful. In Python, we have 2 types of variables. Local variables with the function scope and global variables with the file scope. So in this example, this message variable is a local variable in the greet function. Its scope is the greet function, so we can access it anywhere in this function. Now in Python, unlike languages like C# or JavaScript, we don't have block level scope. So if we define this variable inside of an if block, it is still accessible outside of that block. Let me show you. So here I'm going to add if true colon. Inside of this if block, we're defining the message variable, but it's still accessible outside of the if block. So here we can print message. The same applies if we have a loop here, a for loop or a while loop. So in Python, we don't have block level scope. No matter where we define a variable in a function, it is always accessible in that function after it is defined. So that's all about our local variables. Now let's talk about global variables. If we put this message variable outside of this function, now it's a global variable, so it's accessible anywhere in this file, in any functions. So here in the greet function, we can print it on the terminal. Let's take a look. So here we call greet, run the program, we get A. Now let me show you something interesting. Here in the greet function, I'm going to assign a new value to the message variable. Let's set it to B. Run the program again. Obviously, we get B. However, if I bring this print statement outside of this function and run the program again, let's see what happens. We get A. What's going on here? Didn't we change the value of the message variable? Not really. In this case, this message variable becomes a local variable in the greet function because by default, Python enforces good programming practices. As you probably know, global variables are evil. We shouldn't change them in a function because this can cause a side effect in other functions. So in this case, when Python interpreter sees line 5, it will create a new local variable called message, even though it has the same name as our global variable on line 1. These two are completely separate. Now, I've seen some tutorials and books teaching you bad programming practices. They show you how to modify the value of a global variable inside of a function. So this is how we do it. We use the global keyword and reference the message variable. When Python interpreter sees this, it will realize that in this function, we don't want to create a local variable. We want to use the global message variable that we defined earlier. Now, if we run this code, instead of A, we're going to get B, because the changes will be visible after we exit this function. And that is the reason I said you should avoid using global variables, or if you really want to use them, make sure not to modify them inside of a function, because this can create a side effect in other functions. Maybe other functions rely on the original value of that variable. So, avoid using the global statement. It's a bad practice. It's evil. All right, let's finish up this section by looking at debugging in VS Code. So I have this simple program with this multiply function that we talked about earlier. If you want to follow along with me, head over to bit.ly/pygist, G-I-S-T. Here on GitHub, you can see my gist. Simply copy paste this code. We're going to use this code to explore debugging in VS Code. So below this function, we have 3 statements to print start, the result of calling the multiply function, and print finish. So to start debugging, first we need to add a breakpoint. So here on line 8, you can use your mouse to put a breakpoint here, or if you have taken any of my courses before, you know that I always put a lot of emphasis on using your keyboard because professional developers use their keyboard, not their mouse. So using F9, you can add or remove a breakpoint. Now open up the debugging panel. Here on the top, click this icon here. This will create a JSON file called launch.json with a bunch of configuration for debugging. You can see this file in the project folder inside of this VS Code folder. Here's launch.json. Now you never have to touch this file. We just have to create it the first time. Now let's close this. Back to the debugging panel. Now after this file is created, in this drop-down list, you can see various configuration options for a debugging session. From this list, select Python, current file, integrated terminal. So we're going to debug the current file in the terminal that is integrated inside of VS Code. There is also another one with an external terminal. Now to start a debugging session, press F5. So here on the right side, you can see my integrated terminal. I'm going to close this because it's cluttering the view. So here is the breakpoint activated. Now we are on this line. We can step over it by pressing F10. If you're on a Mac keyboard, you should hold the function key that is on the bottom left corner of your keyboard. So step over. Now on line 9, we are calling a function. So we want to step into this function to see what is going on there. For this, press F11. Now here we are inside of the multiply function. On the left side, inside the variables panel, you can see the variables that are local in this scope. So we have numbers, which is the argument passed to this function. Let's step over one more time at F10. Now we are at the beginning of our loop. One more time F10. Now at this point, you can see a few other variables here. So we have our total, we have the current number that is picked in this iteration. You can also create watches here if you want to look at the value of a variable that is not listed in this panel. Now, let's say you inspected all the variables and you want to step out of this function. To do that, press Shift and F11. Now we are out, back on line 9, F10 one more time, and one more time, and the debugging session is finished. All right, let's finish up this section by looking at a few very useful shortcuts for writing code fast. First, I'm going to show you the shortcuts for Windows users, and in the next lecture, we'll look at the shortcuts for Mac. So if you're a Mac user, feel free to skip this lecture. So here we're on line 9, and my cursor is right at the beginning of the line. Let's say we want to move the cursor to the end of the line. Instead of pressing the right arrow to go all the way to the end, we can simply press the End key, and here's the cursor. Or if you want to move the cursor to the beginning of the line, simply press the Home key. There you go. Similarly, if you want to move the cursor to the beginning of the file, press Ctrl and Home. Here it is, or Ctrl and End to go to the end of the file. Now let's say we want to move this line up. Instead of cutting it from here and then copying it somewhere else, we can simply move it up by pressing Alt and the up or down arrows. Or if you want to move these two lines up and down, simply select them, then hold Alt and then up or down. Very easy. Now, if you want to duplicate a line or multiple lines, simply select them. Now hold down Shift, Alt, and then press the down key. You can duplicate it as many times as you want. There you go. Here's another useful shortcut. If you want to convert this line or maybe these two lines into a comment, simply hold down Control and press /. Using the same shortcut, you can remove the comment, so you can toggle it. Very easy. And finally, if you want to type the name of a variable or a function like multiply, you don't have to type all characters. Here are a few ways to type this quickly. You can just type the first few characters, and here in the IntelliSense, you can see that. So if you press enter, this is what we call auto-completion. Here's another way. So instead of writing the first few letters, you can just pick any letters in sequence and type them. So I can type MTY, or I can just type MPY or MY. There you go. Here it is. So I hope you enjoyed these shortcuts, and thank you for watching. All right, now let's take a look at the shortcuts for a Mac keyboard. So here we are on line 9, and my cursor is right at the beginning of the line. If you want to move the cursor to the end of the line, instead of using the right arrow to go all the way, simply hold down the function key and press right. Here it is. Or you can press function and left to jump to the beginning of the line. Similarly, you can press function and up to go to the top of the file, or function and down to jump to the end of the file. Pretty useful. Now let's say you want to move this line up. Instead of cutting it from here and then copying it somewhere else, you can simply move it up by holding down Alt or Option and then pressing the up arrow or down. Very easy. Or we can select these two lines, hold down the Alt or Option key, move it up or down. Here's another useful shortcut. We can convert these two lines into a comment by pressing Command and /, and then we can remove the comment using the same shortcut. So we can toggle it. And finally, if you want to type the name of a variable or a function like multiply, you don't have to type all the letters like multiply. That is very slow. You can type the first few letters like malt. And here in the IntelliSense, you can see it's selected, so press enter. Or you can pick any characters in sequence and type them, like MTY, here it is, or we can type MPY or MTP. So you can abbreviate it any way you want. I hope you enjoyed these shortcuts, and thank you for watching.